All right, so to start with today, I'm throwing some simplifying types of problems out at you so that we can see what do you already know and what don't you know, because we're going to be moving forward and, of course, adding more and more skills. For this first one, can you already simplify that one? Do you already have the skills to simplify that one? Yeah, I think so, because you'll notice that this first one is just a matter of combining like terms. And so you'll notice that the like terms here are only the squares. So I'm going to be able to combine those. Now, since I can only combine those, though, the 5x cubed, it's still 5x cubed. And that minus 5 hanging on the end, it's still going to be hanging on the end as it was. But for those middle two, I got to do negative 8 plus 2. What's negative 8 plus 2? Negative 6. And that's going to be negative 6x squared. Remember that if they have to be the same, it's because they're going to stay the same. All right, and then the minus 5, again, it stayed the same. So there's your final answer. 5x cubed minus 6x squared minus 5. For the second one, do you remember how to do that type? Well, this is where we're more into a maybe, maybe not sort of problem. When you take a look at that, notice there's two different things inside the parentheses. We have a 2 inside the parentheses, and we have an x to the 5th inside the parentheses. So in order to simplify this one, I'm going to end up having to do 2 cubed, and I'm going to end up having to do x to the 5th cubed as well. So there's two different rules we have to remember in order to do that. First of all, for 2 cubed, remember to cube something means to multiply it by itself 3 times. So 2 cubed just means to do 2 times 2 times 2. Okay, well, 2 times 2 is 4. And 4 times 2 then gives us 8. And so then, that's going to equal 8. Now I go to the x's. I have x to the 5th cubed. I'm going to have a bunch of x's. And again, cubing it means multiplying it by itself. So it's like having x to the 5th times x to the 5th times x to the 5th. Which if we wrote it out the really long way, which I really don't want to do, but probably should, there's x to the 5th. There's another x to the 5th. And then need room for another x to the 5th. How many x's do I have there? 15. And so it ends up equaling 8x to the 15th power. And so you'll notice that when we had the power to the power, our rule was that I multiplied the exponents. We'll be taking time with lots of exponent rules, making sure we know how they all work. But the rule is that a power to a power, you multiply the exponents. All right, next one. In this case, I have an x squared that's outside the parentheses. And in order to simplify this, I want to get rid of those parentheses. So in this case, that's going to mean I'm going to want to multiply this x squared into both of those terms. So that means the first thing I do is I do x squared times 4x. Now, am I allowed to do x squared times 4x? Yeah. They do not have to be like terms here. They can be different because we're multiplying. It's adding and subtracting where they have to be like terms. All right, so when I do x squared times 4x, that means I'm going to do 4 times x squared times x. Now remember that x squared means 2 x's multiplied together, and I'm multiplying that by another x. So notice it ends up giving me x cubed, because I'm multiplying 3 x's together. And then the minus in between them. The minus in between them stays the same. And then I multiply the 4x squared, just x squared, I forgot. X squared times 10, well, that's just going to be 10x squared. So notice I just took whatever was outside, and I multiplied it into each term on the inside. All right, fourth one. Can we do that one? Oh yeah, we can definitely do that one, because this is another one of those that's just a matter of combining like terms. So first up, I have x to the 6, and I have 2x to the 6 down here, and that's all of them that are x to the 6. So I combine those first. So x to the 6 plus 2x to the 6 will give me 3x to the 6, yes. All right, and then I got squared here, so I'm circling my squareds. Okay, so I've got negative 3x squared plus 1x squared plus 2x squared equals how many x squareds? 0. Yeah, because I ended up doing negative 3 plus 1 plus 2. Negative 3 plus 1 is 2. I'm sorry, negative 2. And negative 2 plus 2 ends up giving me 0. So since that's 0x squared, that means all the x squareds are gone. So that is actually my final answer at 3x to the 6th. Nothing else there. All right, and then for the last one, there's actually two different things I can do to simplify that. The first thing I can do is I can actually distribute in like I did on that problem back there, the third one that we did. So I could multiply this into every single term, but I can actually make that process a little bit easier by doing something else first. Because you'll notice I can in fact combine some like terms here on the inside. And if I do that first, I make my life a lot easier. And so I'm just going to do that. Nothing else is changing yet. So it's going to be 3x times x squared. I have 5x minus x. If I have 5 x's and I take one away, I'm left with 4 x's. All right, then the plus 1. Now we'll go ahead and multiply that 3x in. So we're going to do 3x times x squared. That's going to give me 3x cubed. Because x times x squared, that's a total of 3 x's being multiplied together. Then plus, I now multiply the 3x by the 4x. So I do the 3 times the 4, which gives me 12. And then I do the x times the x, which is x squared. And finally, I'm going to do 3x times the 1. Well, anything times 1 is just itself, so that's going to just leave me with the 3x. And that one is now completely simplified. A little side note here. If I had chosen to do that multiplication, or in other words, the distributive property first, and then combine like terms, you'd still end up with the same answer. So that'd be perfectly fine if you chose to do it that way. So the main bulk of our work today is going to actually be dealing with a way of describing polynomials. And there's going to be two different ways we can describe polynomials. The first of those is to describe them by their degree. Now, in order to do that, you're going to need to have this information handy. So go ahead and write this down into your notes. All right, and then when you go and write these down, you'll notice at the end of these, when we get to degree 6 and degree 7 there, notice that's all they are given. They're just called degree 6, degree 7. So I'm only going to expect you to have the vocabulary names down up through a degree 5 polynomial. Anything after that is just degree whatever. So degree 9, degree 10, of course it goes on forever. But these you do need to know. So when we talk about quadratics, you've actually seen quadratics this year already, right? You graph quadratics. Remember what made a quadratic a quadratic? It had an x squared in it. You'll notice then that means the highest exponent was 2. That's why we call it a quadratic equation. Now, you'll notice here that I called this section classifying it by degree. That's because technically speaking, the degree of a polynomial is whatever its highest exponent is. All right, so knowing that and having these notes down, I now want you to be able to use them. So please take a moment, classify, actually write down, and then classify each of these polynomials according to their degree. All right, now let's take a look at that first one to make sure you're on the right track. Then I'll give you a little bit more time to do the others. So on that first one, there's actually 3 different terms. I only care about one of those. Remember in our notes, the degree is determined by the highest exponent. And so, what is the highest exponent here in the first one? The highest exponent here is the 2. And so, we then go to our table and we say if the highest exponent is 2, what do we call that? And the answer is quadratic. So we would call that quadratic. So notice that's our thought process. That's our method. We look to see what is the highest exponent, and then we use that to find the name. All right, so for the next one now, we got x plus 4. So if we're doing x plus 4, this is often one that brings up a question, though, about what is the highest exponent. Well, first of all, actually, let me try writing it out a very long way. I could rewrite this as x to the power of 1 plus 4, and if I want to force an x in there, it'd be like x to the 0. So this is really what we're looking at, where if I don't write an exponent in on the x, that means it's the 1. And if there's no x there, that means the exponent is 0. And so then the highest exponent in this case is 1. That's why that one would be called linear. All right, for the next one, x squared minus x to the 4th. Now typically, the highest exponent will be the first one. If we're actually keeping with really good form and all that, that'll be the case. But it's not always written that way. Because in this case, yeah, the 4 is your highest exponent. Therefore, we are going to call that quartic. All right, the negative 3. What's that? Well, that one has no x in it at all. Therefore, it's degree 0. So that one is constant. And you can kind of see why it's called constant here, because if it's negative 3, it's always negative 3. You could say x is anything, but this still equals negative 3. It's a constant value. All right, now this last one. This last one's going to be a little extra tricky, because there's two different answers we could possibly come up with on this one. One possible answer is that we could say that it is quintic, because the highest exponent here is a 5. However, you notice that the 2x to the 5th minus 2x to the 5th, they would cancel each other out. So that whole thing actually equals 8x cubed. And then I could say that it's cubic. So which one is it? Well, we always want a single right answer in math, which is why simplifying is such a big deal, because we want to all be able to write something in the same way. And so when we're classifying these polynomials, if it can be simplified, we simplify it first, which is actually partly why we did that simplifying practice at the start of class. And so I would actually classify it based on the 8x cubed. So this would be considered a cubic polynomial then. This was all classifying based on the degree of the polynomial, which is actually the hardest part. But there is one other part to get in. We can also classify a polynomial based on its number of terms. And so please also add this into your notes, and then we'll see what this looks like and how it gets applied as well. All right, so for these, this is all classified by number of terms. Now this does require, of course, you remember what the terms of a polynomial are, right? So a quick refresher here. The terms of a polynomial are always the parts that are separated by addition and subtraction. So basically, it's how many different pieces are being added or subtracted all together here. And so that's what we're going to be looking for. Now, in this case, notice there's only 3 things that you actually have to remember as specific vocabulary: monomial, binomial, and trinomial. After that, it's just a polynomial of so many terms. Because all of these are types of polynomials. It's just a matter of how specific we are getting about those polynomials. All right, now to practice this idea, again, I'd like you to go ahead and please classify each of these polynomials based on their number of terms. So for that first one there, remember terms are separated by addition and subtraction, so I have a term here, a term here, and a term here. So you notice then I got a total of 3 terms. Therefore, this is a trinomial. All right, from there, the next one. Notice there's only one term, so that one is a monomial. All right, the next one, the third one down. Notice there's nothing I can simplify, so that's as good as it gets. That is just going to be a polynomial, which is our generic term, remember. This one of 5 terms. And yes, we actually need to write the of 5 terms part. The fourth one, yes, the b counts as a term. So that fourth one, that is going to be a binomial. And that last one, It looks like I can do a little bit of simplifying there, because I got the 7x cubed plus x cubed, that's 8x cubed, minus 8x cubed, well that's 0, so that one just went away. So actually this whole thing actually just equals negative 5x, which means that one is a monomial. All right, you've now classified first by degree, second by number of terms, and total classification is actually doing both. And so what we're going to do for these is we're going to classify each of these by the degree and the number of terms. If you're just asked to classify a polynomial, that's what it means. It means by degree and number of terms. So write down that first one. Then I want to make sure we see the thought process that goes through on it. And so for that first one, the first thing we do is we always start with the degree part. And so degree, what is the degree of this first expression? Well, the highest exponent is a 2. Therefore, yes, we call that quadratic. So the first thing I write then is quadratic. That's the degree part. Then I go to number of terms. And so I have to count how many terms do I have. I got 2. And so if there's 2 terms, then it is a binomial. And so then that would be total classification. That one ends up being a quadratic binomial. Repeat the process for the remaining 4, please. So the first 4 were fairly straightforward, but this last one, it looks a little different. And so again, we got to think about how do we deal with it. Well, remember it has to be simplified first. And in this case, this is one of those where I can distribute that x into both terms. And I actually have to do that first. So I'm going to do the x times the 6x squared, which gives me 6x cubed. Then we do the 1 times the x, and that gives me x. This is now fully simplified. So this is then what I'm using to classify it. And so the highest exponent is a 3, so therefore cubic. And there are 2 terms, therefore binomial.